If I have a problem like this where my goal is to simplify this radical, I start by factoring. My goal is to factor down to numbers that are prime, that can no longer be divided. So with a number like 72, maybe it just pops into your head that 72 is 8 times 9. That would be great. If it doesn't, you can look and see like, oh, this ends in a 2, so it's even, so I can divide it by 2. You could divide it by 2, then you could see, you get 2 times 36. You could look at 36 and say, oh, that's also divisible by 2. You could keep going. So it's just any two numbers that multiply. So usually there's multiple options. 8 is 2 times 4. 2 is prime, so I circle it. 9 is 3 times 3. 3 and 3 are both prime. And 4 is not prime. 4 can still be factored, so make sure you continue until you get to numbers that can no longer be divided. Next, you're going to take all these numbers and you're going to write them under the radical sign. So I'm going to write 2. I have 3 2's. And I have 2 3's. And notice I just made a little mark near them as I wrote them so that I didn't lose track of any. So here I'm writing factors under the radical. Okay, now next, I'm looking for doubles. And what I'm going to do with those doubles is I'm going to separate them out. And the reason I'm separating out the doubles is because the doubles simplify in a way that the singles don't. So by separating them, I'm making it easier to simplify. So I have this double, 2, and I also have this double, 3. Now be mindful and don't lose track of the singles. Now the next thing I'm going to do is I'm going to simplify the doubles. Only the doubles can be simplified, not the singles. So this double, what does this equal? Well, there's two ways to think about it. The first is that this is the same as 2 squared and the square root of that. So squared and square root, they cancel. So if I have something squared and something square rooted, they cancel each other out and I'm left with just 2. The other way is to kind of do the math, right, and say, okay, well 2 times 2 is 4 and the square root of 4 is 2. Either way, this square root of 2 times 2 equals 2. And in the same way, the square root of 3 times 3 equals 3. Okay, and these two things are being multiplied together. Nothing happens with this single. There's nothing there to simplify. And then my final step is to do any multiplication there is. Sometimes there's 2 numbers on the inside of the radical here. Sometimes there's 2 numbers on the outside of the radical like there is in this problem. Either way, you multiply. So 2 times 3 is 6. And again, if there was 2 numbers on the inside, we would multiply those together as well. In this case, there's not, and it just stays like this. Let's take a look at the next problem. We're going to go through the same steps. I'm first going to factor. 18 is 6 times 3. Maybe you come up with 9 times 2. Either way, it won't matter. When you're done factoring, you'll end up with the same factors. So I have 2 3's and a 2. And in this case, I also have 3 n's and I have 4 p's. Again, I'm looking for doubles. There's a double, a double, a double, and a double. Okay, and these are singles and they stay inside. When I simplify the doubles, this becomes a 3, this becomes an n, this becomes a p, this becomes a p, and this stays the same. When I multiply, 3 times n times p becomes 3n p² and then the green piece doesn't change or simplify.